Given a single normal distribution, or a set of identical normal distributions, we can find means and standard deviations from probabilities and percentiles. But what if we have normal distributions that don't have identical means or standard deviations? For example, suppose we have a probability of a positive profit and the probability of a profit in the next year. If we assume the yearly profits are normally distributed with the same mean but different standard deviations, can we find the probability that the company earns an overall positive profit during the 2-year period? Let the profits, means, and standard deviations be. We have the probability that x1 is positive, and since this is greater than 0.5, it must correspond to some z-score less than the mean. So as usual, we'll designate it minus z1, and by symmetry, the probability that z is less than z1 is the same. And so we can recover our z-score. And so x1 equals 0 corresponds to z equals negative 1.05. And this gives us a relationship between the standard deviation and the mean. For the second year, we have the probability of a positive profit. And by a similar argument, this corresponds to a z-score that's negative, which corresponds to the probability that we're less than some positive z-score, which turns out to be 1.40. And so x2 equals 0 corresponds to z equals negative 1.4, which gives us another relationship between a standard deviation and a mean. Since the profits are normally distributed, the sum will also be normally distributed, and the mean will be the sum of the means. However, since the means are the same, that's just twice the mean of the first year. The variance will be the sum of the variances, and since the means are the same, this gives us, and consequently our standard deviation will be the square root. And so if our profit is positive, the corresponding z-score will be where the actual value of the mean factors out. And so now we can find our probability. And again, by symmetry, the probability we're greater than a negative is the same as the probability we're less than the positive, and we can look that value up on the table. Or let's consider two different products, both of which are normally distributed, with the fire insurance having 3 times the mean and 3 times the standard deviation. And if one product has a probability of a positive profit of 0.67, let's find the probability of a positive profit from the other. So let x be the profit from flood insurance and y the profit from fire insurance. We're given the probability that x is greater than or equal to 0 is 0.67. And again, this means that x equals 0 must be to the left of the mean. And so let negative c be the corresponding z-score, where we change our variable to c because, well, we felt like it. And so our probability we're greater than a negative is the same as the probability we're less than the positive. And since we know this probability is 0.67, we'll get it from our table. And so x equals 0 corresponds to z equals negative 0.44. And we can substitute these into our z-value formula and find a relationship between the mean and the standard deviation. And so our mean is 0.44 times the standard deviation. Now the sum will be normally distributed, where the mean is the sum of the means, but the mean of the second insurance product is 3 times the mean of the first, and so the mean will be. We also have the variance as the sum of the variances, and again, because our standard deviation of the one is 3 times that of the other, we get, and so our standard deviation is, and so the probability that our sum is greater than 0, that z-score will be, and we know the mean in terms of the standard deviation, and our standard deviations will factor out to give us the actual z-score. And so that probability that we're greater than a negative is the same as the probability we're less than a positive, and we consult the table to get